Okay, so this is still part of section, what was it? 6 point something, 6.2? Yeah, so this is still section 6.2. So this is the last example from 6.2. Okay, so it says mountain officials want to find the length of a new ski lift from, there's a drawing, so the letters are going to refer to the drawing, from A to C. They measure angle DAC to be 33 degrees. They move 1,220 feet to point B and measure angle DBC to be 22 degrees. What is the length of the new lift from A to C? Ugh, it's a lot of writing, right? These word problems. This one comes with a picture. So basically there's a mountain. So here's our ski mountain. And here is point D at the bottom of the mountain. Here's point A. And out here is point B. And so the problem tells us that so they're trying to find the length of a new ski lift from A to C. And so point C is actually here at the top of the mountain. So we're looking at trying to find this. So here's our new little ski lift, right? There's the little chairs of the lift going up. And the old lift, right, used to go here from C to B. So that's kind of the picture they give us. So they tell us the measure of the angle DAC. So DAC, so they're talking about this angle in here is 33 degrees. And then they say they move back 1,220 feet. So the distance from here to here is 1,220 feet. And then they measure this angle, and it is 22 degrees. So that is the triangle that we're trying to deal with. And we don't know, it kind of looks in my drawing like D is directly underneath C, and maybe you could make a right triangle, but we don't know that for sure. So we're going to be basically stuck using just this pink here triangle. And so I happen to know one side of the triangle, so I can hopefully use the law of sines to help me figure out what I'm looking for. However, to be able to do that, I need to figure out some angles. So I know the 22. Here I have 33 degrees. What happens, so that 33 degree angle and this blue angle in here, so together, does anybody know how much together those two angles make? Yeah, so they form a straight line, so they make 180 degrees. So this blue angle in here is going to be 180 degrees minus 33 degrees. And that is 147 degrees. And then remember, all the angles in a triangle make 180 degrees. So if we want to find that angle up there at C, 180 degrees is going to have to be C plus 147 degrees plus 22 degrees. And if you work that out, C ends up being 11 degrees. So this angle in here is 11 degrees. Questions so far? No? Yeah. Oops, wait a minute. Let me turn up my sound because I had it kind of low. Okay, say that again.
So from there, do you subtract the 11? Like, do you do the same thing that you did to the 33 to the 11?
No. So I'm not. So I'm just gonna leave the 11 as 11 in there. The reason I took the 180 minus the 33 is because the 33 degrees was outside of my triangle, and I was trying to find the angle inside my triangle. So to find this blue angle here, this angle plus the 33 degrees gave me 180. So that's how I got that the blue angle here was 147 degrees. And then I have a triangle here, and so all three angles in the triangle add up to 180 degrees, and that's how I found the 11. And now I know all the angles inside my triangle, so I'm done. I don't have to do anything else with those angles. Does that help?
Yeah.
Any other questions? Yeah, so the answer is going to be, we're going to try to find little b, right? Because we're not done with the problem yet. We're trying to find this side here, how long this ski lift is. Since it's across from big B, it is little b. And so we're going to use the law of sines, right? So the law of sines says that the sine of big B over little b is going to be the same as, so now if I look, I know big C is 11 degrees, and I happen to know little c here is 1,220. So sine of B over B is going to be equal to the sine of C over C. And so if I plug in here, we're going to have the sine of 22 degrees over B is going to be the sine of 11 degrees over 1,220. So I'm going to cross multiply. So 1,220 times the sine of 22 degrees is going to be B sine of 11 degrees. And then I'm trying to get the B by itself, so we're going to divide both sides by the sine of 11 degrees. So those are going to cancel. So our B is going to end up here being roughly 2,395.2 feet. Okay, so little c is 1220 because, so I know there's a lot going on in this picture, right? But if you were to like kind of take my pink triangle and redraw my pink triangle, right? This is what's going on in this pink triangle. This angle here is 22 degrees. We call this angle A, B, C. A is 147, C is 11, right? So those are the angles we found in our triangle. And then I found that this side here, we were told this side there is 1220. So really we're just dealing with that triangle in the law of sines, right? So the sine of 22 over, this is what we're looking for, little b. So the sine of 22 over little b is going to be the sine of 11 over 1220, because 1220 is across from the 11. No problem. Any other questions? No? Okay, so that's the end of the law of sines section. So what we're going to do now in a minute when I turn the page here is we're going to do the law of cosines, so section 6.3. And this is the end of what the take-home test is on. So the take-home test is just on chapter 6, so 6.1, 6.2, 6.3. Does anybody need me to wait before I go to the next page? Nope. Okay, so this is section, section 6.3, the law of cosines. Okay, so we're not going to derive the law of cosines. You could derive it kind of very similar to like how we did the law of sines the other day. We're just not going to get into all of that. So I'm just going to write down what the law of cosines is. So the law of cosines can actually be shown in 3 different ways. So there's 3 different forms for it. So given any triangle with angles capital A, capital B, and capital C. The law of cosine says a squared plus b squared plus c squared minus, not plus, sorry. A squared, let me just rewrite this. A squared is equal to b squared plus c squared minus 2ab, not AB, 2bc cosine A, or b squared is equal to a squared plus c squared minus 2ac cosine B, or c squared is equal to a squared plus b squared minus 2ab cosine of C. So, it basically pairs up, it pairs up whatever side you're looking for. So here, like I have the side A on the left-hand side, then I'm going to have a cosine of angle A. If I'm dealing with side B, I'm going to have a cosine of capital B. If I'm dealing with side C, I'm going to have a cosine of capital C. Generally, which one of these you use, which formula, the first one, the second one, and the third one, depends on what side of the triangle you happen to know. So a lot of times it's what angle, right? You might only know one of the angles, and you might not have a way to get all 3 angles, which you would need all the angles to be able to use the law of sines. So this helps us out. The law of cosines is also nice because unlike the law of sines where you might have those multiple cases like we did last time, in the law of cosines you don't get multiple cases. So the law of cosines, like what you get is what you get. That is the answer. You don't have to worry about doing multiple cases. So for example, solve the triangles. A. Capital A equals 98 degrees. Lowercase b equals 47. Lowercase c equals 42. So just like before, I am kind of a more visual person. I like to be able to see what I'm looking at. So I draw some generic triangle, and then I label the sides, right? So A, B, C. So A is 98 degrees, little b is 47, and little c is 42. So, remember, solving the triangles, we're trying to find all the missing sides and all the missing angles. So, in this case, we could find either one that we want. We could find either one that we want first. So do you want to find little a, or do you want to find one of the missing? Well, I guess we need little a first. I shouldn't say that. So if you notice, I have capital A, right? I have the angle capital A, and I don't have all the three sides. I'm missing little a, so we should use this first version of the formula to help us find little a to begin with. So we're going to plug into a squared is going to be equal to b squared plus c squared minus 2bc cosine of a. So a squared is going to be equal to, b is 47, so 47 squared, c is 42, plus 42 squared, minus 2 times 47 times 42 times the cosine of 98 degrees. Questions on anything I did there? Okay, so somebody asked me, could you use the tangent? So you can't use the tangent because the thing is we don't have a right triangle, right? So in my triangle here, there's not an angle of 90 degrees. So you can't just use the trig functions straight up because you don't have a 90 degree triangle. Does that make sense? Yeah, so the trig functions only work on right triangles. So the trig functions just by itself only work on right triangles. The law of sine and the law of cosine work on any triangle. No problem. Other questions? No? Okay, so what we're going to do is we're going to calculate out what this is. So if you work that out, a squared is going to be equal to 4522.4554. If at all possible, like as you're doing intermediate steps in these problems, you want to try to leave at least 4 decimal places so that you don't kind of get big rounding errors. So now we're going to take the square root of this. So technically when you take the square root of both sides, you're technically getting plus or minus. But in this case, we're just dealing with a triangle, so we're only worried about the positive part here. So this is going to be the square root of 4522.4554, and that is approximately 67.2. So now I know that this side here is roughly 67.2. Questions? No? Okay. So now we want to find either angle C or angle B. So let's find angle B. It does not matter which one you find next. I just want to find angle B because that's the one that I have the answers worked out for on my paper with all the middle steps. So you could just as easily find angle C and then use angles C to help you find angle B. But instead we're going to find angle B. So because I want to use angle B, that's what's telling me I have to use this formula here, right? To find B, I need to use this formula because I'm dealing with angle B, right? So if we take B squared equals A squared plus C squared minus 2AC cosine B. And I'm going to move this, I'm going to move this up so that we can see what's going on here. So we're going to plug in. So little b is 47, so 47 squared equals little a, we just found it's 67.2, so 67.2 squared, plus little c is 42 squared, minus 2 times 67.2 times 42 times cosine of B. So all I've done is plugged in. And now I'm going to calculate out. I'm going to do those multiplications. So 47 squared is 2,209. 67.2 squared plus 42 squared. So these two things added together gives me 6,279.84 minus 2 times 67.2 times 42 is 5,644.8 times cosine B. Questions? No? Okay, one of the biggest mistakes that people make in these problems is at this point they try to do this subtraction. So yeah, I mean, it's just algebra from here for the most part. But you cannot subtract these two numbers, right? This number here is attached to the cosine. This is all one piece. You cannot just subtract these two things, right? So we have to bring the 6,279.84 to the other side. So minus 6,279.84 minus 6,279.84. So on the left-hand side, we're going to have minus 4,070.84 being equal to minus 5,644.8 times the cosine of B. I'm trying to get the cosine of B by itself, so we're going to divide both sides by minus 5,644.8. So divide by minus 5,644.8. And if you do that, you get that the cosine of B is about 0.7212. And so what would I do to figure out B? If B is trapped inside the cosine, what am I going to do to figure out what B is? Yeah, take the inverse cosine. So B is going to be equal to the inverse cosine of 0.7212. And if you work that out, B is approximately equal to 43.8. So this is roughly 43.8 degrees. Should put a degree here. And then finally, I have two of the angles, so I need to find all three angles of the triangle. So I know that angle C plus angle A plus angle B has to be 180 degrees. So angle C plus 98 degrees plus 43.8 degrees equals 180 degrees. And so if you work that out, C is equal to 38.2 degrees. So 32.8 degrees. Questions? No. So the problem with these problems, with the inverse cosine problems, is the numbers are usually a lot bigger and messier than they are in the inverse or in the law of sine problems. But the law of cosines, remember, you don't have to do multiple cases. So if you can use the law of cosines, if you have a choice between the law of cosines and the law of sines in a particular problem, the law of cosines, you don't have to do two cases. There are times you must use the law of cosines. There are times you must use the law of sines. It kind of just depends on what you were given in your triangle to begin with. Does anybody need me to wait before I go to my next page and do my next example? Okay, you couldn't have used the law of sines like at the beginning, right? So at the beginning, remember, like the original triangle they gave me was this, right? This was 98 degrees, this was 47, and this was 42, right? This was my original triangle. I couldn't have used the law of sines right then because remember, to use the law of sines, you need an angle, you need one known angle and known opposite side. Like you have to have that pair. And so here, I don't have a pair already, right? So I have to start using the law of cosines. You could have to find B once you found once we found that A was 67.2 after that first step, you could have used the law of sines to find angle B or angle C. But again, you're going to end up in that potential where you have to look at, do I have two choices, two answers? So that's why I just stuck with the law of cosines. Plus, I want to give you a bunch of like examples of law of cosines. How do you know when you can use the law of cosines instead of sines? Okay, so the law of cosines, basically, you either have to be given, so if you look at the beginning here, I had a side, an angle, and a side. So if you're given two sides and one angle, you can use the law of cosines. So anytime you have two sides and one angle, you can use the law of cosines. You can also use the law of cosines in my next example when you are just given all the sides. Does that help? No problem. Other questions? Okay. So let's try another one here then. One where I have all the sides. So on the test, somebody asked me, like, on the test, am I going to say which one to use? No, on the test, you're going to have to figure that out. But again, that's why this test right here is a take-home test, right? So you can, like, look at your notes, you can look at the examples I've given and stuff like that. So it's not like you have to, like, remember and do it, like, during the test. So the test I'll put the test up on, it'll be there on Wednesday for us to talk about. And then you'll have a week. So it's kind of like, think of it more like another homework assignment, but not one like on Alex that's going to tell you right away whether you're right or wrong. No problem. Okay. So part B, A is going to be 49. B is going to be 22. And C is going to be 55. And so again, if I draw some random triangle and label it A, B, C, little a is 49, little b is 22, little c is 55. And again, obviously, my triangle is not drawn to scale, right? Because the longest side is actually, is 22, right? So I just need a triangle kind of so I can place things so I can kind of see what's going on. Okay, so we want to find one of the angles first, right? In this problem, we were given all of the sides, and we want to find one of the angles. So we might as well do them in alphabetical order. So we'll start with A. So if I'm looking to find angle A, I'm going to use the version of the law of cosines that had angle A in it. And that version is that A squared is equal to B squared plus C squared minus 2AB, oops, not 2AB. I keep wanting to do that today. 2BC cosine of A. And so now we're just going to plug in. So little a is 49. So 49 squared is going to be 22 squared equal to 22 squared plus 55 squared minus 2 times 22 times 55 times the cosine of A. Questions? let me know when you're ready for me to keep going. Okay. So now we're just going to figure each of these things out, right? So 49 squared is 2,401. 22 squared plus 55 squared. So if I work those two things out and add them together, those together are going to be 3,509. And then if I multiply 2 times 22 times 55, we're going to have minus 2,420 times the cosine of A. Questions about that so far? Okay, and again, just like before, you cannot take 3,509 and subtract off the 2,420 because the 2,420 is attached to the cosine of A. So this is all one piece, and you cannot separate it. So we're going to subtract 3,509 from both sides. And if we do that, we have minus 1,108. Is equal to minus 2,420 times the cosine of A. And then I want to get the cosine of A by itself. So I'm going to divide both sides by minus 2,420. And so A, so if I work this out, this is 0.45785. That's equal to the cosine of A. And again, notice I put a lot of decimal places there because this is just one step in doing this problem. It is not the it's not the final answer for doing this problem. And so now A is going to be the inverse cosine of this, so inverse cosine of 0.45785. So A is going to be equal to roughly 62.8 degrees. So I'm going to fill that in here, so 62.8 degrees. So I've got my A now. So questions on anything I did there? I'm going to kind of move this up a little bit. Yeah, you're pretty safe if you use 4 decimal places. I think Alex even says, like, if you're rounding in middle steps, round to 4 decimal places. So yeah, if you do 4 decimal places, you're pretty safe. Other questions? Okay, so I have A. So we're going to find B now. So again, you could at this point, if you wanted to, because you now have this angle and this side, you could use the law of sines. However, we're going to use the law of cosines for a couple reasons. One, I want to give you guys enough practice, be able to let you see me do the law of cosines more times. 2, the other reason is because if I use the law of sines, I'd have to use the 62.8 degrees. And remember, the 62.8 degrees is a rounded answer. If I use the law of cosines again, I don't have to use the rounded answer in this case. So to find b, we're going to use the law of cosines formula that says b squared is equal to a squared plus c squared minus 2ac cosine of capital B. And so just like before, we plugged in what little a, little b, little c are. We're going to do the same thing here. We're going to plug in what little a, little b, little c are. So little b is 22, so 22 squared. Little a is 49, is going to be equal to 49 squared, plus little c is 55. 55 squared minus 2 times 49 times 55 times the cosine of capital B. So questions so far? No? Okay, so 22 squared is 484. Again, 49 squared plus the 55 squared is 5,426. And then 2 times 49 times 55 is minus 5,390, all times the cosine of B. Just like before, I'm going to subtract the 5,426 from both sides. Minus 5,426. So we end up with minus 4,942 is equal to minus 5,390 times the cosine of B. And just like before, divide both sides, minus 5,390. And kind of running out of room, so I'll come up here. So we end up with 0.916883, just because that's how many decimal places I've written on my paper, is equal to the cosine of B. And so B is going to be the inverse cosine of 0.916883, or B is going to be roughly equal to 23.5 degrees. So I know this angle B here is 23.5 degrees. And now that I know that angle B is 23.5 degrees, I can find angle C, because remember all those angles add up to 180 degrees. So 62.8 degrees plus 23.5 degrees plus C has to be 180 degrees, and if you do that, C should be 93.7 degrees. Questions? No? Okay. Does anybody need me to wait before I do my next example? Okay. All right. So I have 2 word problem examples here. So Sam wants to find the length of the tunnel drawn, shown. Help him find the length. Okay, so there's a mountain, and there's a tunnel going through the mountain. So we did a tunnel through the mountain before when we were doing the Law of Cosines problem, or no, I guess it was when we were just doing the right triangle problems. So now we're going to come back again. So Sam is standing here, and he takes a measurement. So we'll call this side of the tunnel A, and we'll call this side of the tunnel B here. So there's our points. And he finds out that this angle here is 75 degrees, and he can measure from himself to point A. So that is 230 meters. And from himself to point B is 173 meters. And we'll call Sam here is at point C. So we are trying to find little c. So again, if I look at the problem, right, I don't know an angle and a pair and a side pair. I don't have that worked out. So that's indicating again that I should use the law of cosines. Anytime you have a side and the angle in between those two, you have 2 sides and the angle in between those 2 sides, that's indicating that it's going to be a law of cosines problem. And the angle that we have is capital C. So that means we're going to use the law of cosines that has the capital C for the angle. So that law of cosines, it says C squared is equal to A squared plus B squared minus 2AB cosine capital C. And so if I plug in here, little c we don't know, that's what we're looking for. But we happen to know little a, it's 173. So 173 squared. Plus I know little b, it's 230 squared. Minus 2 times, little a is 173. Little b is 230. Cosine of angle C, which is the cosine of 75 degrees. And if you punch that in your calculator, you should get that little c squared is equal to 62,232.18039. We're looking for c, so we're going to take the square root. So c is going to be the square root of 62,232.18039, or roughly 249.5 meters. Questions? So like I said, the law of cosines I actually think is a little easier than the law of sines because you don't have to worry about those multiple cases. But the trade-off for that is you have to deal with ugly numbers. So I do have one more word problem example. Does anybody need me to wait before I go to the next page? No? Okay. So this is 2 airplanes leave an airport at the same time. An hour later, the planes are 228 kilometers apart. One plane has traveled 288 kilometers, while the other has traveled 283 kilometers. Find the angle between the 2 planes. Okay. So again, drawing a picture is helpful. So let's say that this dot here is the airport, right? So you got 2 planes. They flew out of McCarran last night. One goes this direction. Okay, so here's one plane. Okay, my planes are not the best here. And another airplane goes this direction. Right, that doesn't really look any better. That doesn't even look like a plane, but kind of put that on there. But you get the idea, right? So 2 planes, they're going in each direction. Okay, so it says they've flown, and then it tells us that the distance between these 2 planes. So this distance between the 2 planes are 228 kilometers. And it says one plane, right, traveled 288 kilometers, and the other plane traveled 283 kilometers. And just to make our lives a little easier, let's call this point up here B, and let's call this point down here C. So I am looking for the angle between the 2 planes, which means we're looking for this angle sitting in here. So this angle, that would be the angle between the 2 planes, how they ended up taking off. Slightly different angles. So again, I know all the sides and I know none of the angles. So that tells me, oh, you should use law of cosines. We're looking for angle A, so I'm going to use the law of cosines that lets me find capital A. So that is that little a squared is equal to b squared plus c squared minus 2bc times the cosine of capital A. Questions? No. Okay, so if we plug in then, little a is 228, so 228 squared is equal to 283 squared plus 288 squared minus 2 times 283 times 288 times the cosine of A. So 228 squared is 51,984. 283 squared plus 288 squared is 163,033. And then 2 times 283 times 288 is minus 163,008 times the cosine of A. And then again, you can't do that subtraction. That 163,008 is attached to the cosine of A. So I'm going to subtract 163,033 from each side. 163,033. So we get minus 111,049 is equal to minus 163,033 cosine of A. Divide both sides by minus 163,033. So the cosine of A is equal to 0.681249. So A is going to be the inverse cosine of that. So inverse cosine of 0.681249. Or A is going to be equal to 47.1 degrees. Oh, we should have. I'm sorry. I just copied that wrong. Yes. I wrote the wrong number here, right? This should have been... Sorry. The other number should be right. 163,008. 008. 163,008. Thank you. Other questions? No. Okay. So that's the end of the law of cosines. There is one other thing in section 6.3 that we're going to do. And that has to do with finding area of triangles. So area of triangles. So does anybody remember the formula for the area of a triangle? So length times width, that's for a rectangle. But good try. Yeah, 1/2 base times height, right? So the area of a triangle is generally, we know the formula to be 1/2 base times height. And so if you happen to know, right, the height of your triangle, that's great, right? So, but you could have a triangle, maybe my triangle kind of looks like this, right? And so this would be my base. To figure it out, I have to know this inside measurement, the height. And the thing is we don't always know the height of a triangle. So there's actually a pretty cool formula called Heron's formula. And Heron's formula finds the area of a triangle using only the sides. It doesn't actually use the height. So Heron's formula says that A is equal to the square root of S times S minus A times S minus B times S minus C, where S is equal to 1/2 of A plus B plus C added together. So, for example, find the area of this triangle here. So this side is 11, this side is 14, this side is 15. So I don't know the height, right? I don't have enough information to help me find the height in this problem, but I can label this. So if I called this, say, A, B, C, then I can use this Heron's formula to help me find the area of the triangle, which is pretty cool. So the first thing you have to do is you have to find S. So S is going to be 1/2, and then we're going to add all of these together. So 1/2, 14 plus 15 plus 11. So this is going to be 1/2. If you add 14 plus 15 plus 11, you get 40. So 1/2 of 40, which is 20. And so the area is going to be, what we do is we take 20 and we subtract off each of the sides. So the area is going to be the square root. So first S by itself, so that's the 20. S minus A, so 20 minus 14. S minus B, so 20 minus 15. And S minus C, so 20 minus 11. So we're going to have the square root of 20 times 9 times 6. Oops, I didn't do those in the right order. Just copying them off my paper. But what do we have to do? 6 times 5 times 9. Or the square root of 5,400, which is roughly 73.5 meters squared. Which I guess I didn't say these were meters, but if these were all meters. So, it's just a little, kind of cool tidbit, right? That's pretty neat. You can find the area of a triangle as long as you know all three sides. You don't actually have to know the height of the triangle. So I think that's kind of cool, right? And it's not something we usually teach people, which I'm not really totally sure why, but we don't. Questions? No. Okay, so that's the end of section 6.3. We're getting close to the home stretch, right? We don't have a ton of stuff left to do. So I will on Wednesday, I will have the take-home test to bring, and I'll have it posted and we'll talk about it. And then I'm hoping to get it up actually tomorrow. So, but we'll definitely talk about it on Wednesday. And then we're going to kind of there's kind of two main topics we have left to cover. So one of those topics is what's called polar coordinates, and the other topic is, so we're going to look at polar coordinates, and then we're also going to look at vectors. So those are kind of the two big things that we have left to do. So it's not a ton of stuff. So yeah, so you've made it through all the big stuff in Math 127, and now we just have this little bit of stuff kind of left to do. So, questions? No? Alrighty. Okay, well then you guys have a good day. Oh, fun question. It's still possible to create a formula these days. You mean to like create a brand new formula and stuff for things? Oh, Gorman's formula. Yeah, I can leave this up, Kelly. So, yeah, I mean, so basically to get my PhD, right, like I had to come up with like my own mathematics that other people hadn't done yet. So that is like anytime you have somebody who gets a PhD in mathematics, like they've essentially have come up with their own little like portion of mathematics. It generally builds on what people have done before, but yeah, you do actually have to figure out your own stuff that no one else has figured out yet. So I guess the answer is yeah, kind of. Hi.
Hi, Ms. Garman. I have a question.
Sure.
When I asked how do you know when to use the law of sines, cosines. When do you use the law of sines instead of cosines? How do you know?
So I would use the law of sines if in the original problem, right? Like so when you like draw your original triangle, you would need to have like say you knew one angle, like say you knew this angle. And you knew this side. So you need to be able to use the law of sines, you need to have a side and an angle that you across from each other that you know at the beginning. Does that help?
Okay. Yeah. Thank you.
No problem. Anybody else have questions?
Yes, I do have a quick question.